All right, so 13.3 homework. The hardest one up here is probably number 3. Now, you're supposed to draw the given angle, then find two angles that are coterminal. Now, when you do 3, most of you guys are just going to have to go ahead and make this thing a degree. You're supposed to know that pi is worth 180 degrees. All right, so maybe you push buttons in a TI-84. I don't know what you do, but you do something. I know that 180 over 3 is 60, so I've got 11 60s, which I think is 660 degrees. So a 660-degree angle is going to rotate once, which is 360, which, by the way, is a coterminal angle, all right? 300 degrees is coterminal. Then it's going to rotate another 300. So take me about right there. And there's my angle. All right. Now, I know that there happened to be roughly 60 degrees of negative rotation to get me back to the x-axis. So these are the two angles I'm going with. Now all you had to do is add or subtract 360 or 2 pi. Now, this was given as a pi rad, so I need to take 300 degrees and I need to change it into a pi rad. I also need to do the same thing with negative 60, but that one's easy. I say it's easy because you were supposed to memorize that pi over 3 is 60 degrees on your circles. So this one's going to be negative pi over 3. There's one of my coterminal angles. 300 is on your unit circle, I feel like it is, isn't it? It takes 5 60s. So 5 pi over 3. And there's two coterminal angles. Something else you could have done here. When you do a coterminal angle with pi rads, what you do is you add or subtract 2 pi. So like in a TI-84, we have our 11 pi over 3. We're not going to put in the pi. If I take away 2, math enter, this will be that guy over there, 5 pi over 3. And if I take away 2 again, of course, you'll see that negative pi over 3. Easy peasy lemon squeezy. Find the reference angle theta. Now, a reference angle is the angle formed with the nearest x-axis. That's what a reference angle is. Always with the x-axis. It's about the x-axis, not the y. None of these look too bad. Let's see here. Let's do 6. So we got our negative 11 pi over 6. We're going to have to make that 180 degrees. And that's going to give me a negative 11 times 30. Because 180 over 6 is 30, which is negative 330 degrees. Now, a negative angle rotates like a clock. So we're going to rotate 180, 270, and then 60 more. Here's the angle. That's what she looks like. But the reference angle is right here, and it measures 30 degrees. Because it's the angle formed with the closest x-axis. Let's see here. I don't want to do all of these. So I did 6. I'm not going to do 8. Let's look at 7. The easiest way to do 7 is to go ahead and just take away your 360. Because coterminality. If I take away a full circle, I still have some rotation left. And that's going to give me 225 degrees of positive rotation, which rotates counterclockwise. You always start on the positive x-axis. I'm going to rotate 180 and then 45 more. That's a 225 degree angle on your unit circle. 45 degrees is your reference angle. All right, evaluate the function without using the calculator using the reference angle theta. Draw the angle, find its reference angle, and use your knowledge from there to evaluate. Drawings must be shown. I want these done using 30, 60, 90s and 45, 45, 90 patterns. Do not forget ASTC, all schools torture children. All right, so the first one I'm going to do here is going to be the sine of negative 150 degrees. That's going to rotate clockwise. It's going to look something like that. So I rotated 150 degrees. If I would have rotated through 2 quadrants, that would have been 180. 180 minus 50 is 30 degrees. And this is my quadrant. I'm going to triangle that guy out right there. Opposite of a 30-degree angle is a 1. It's falling, so it's negative. The hypotenuse is twice the short leg, and the long leg is the short leg times √3. Negative because it's running left. Your task here was to find the sine of that angle by using the reference angle. Now, sine is opposite over hypotenuse, so -1/2. The reason we talk about ASTC is because in this quadrant, tangent is supposed to be positive, so is cotangent. Sine is supposed to be negative. All right, let's look at 12, the tangent of 240 degrees. That is a positive angle. We're going to rotate 180. That leaves 60 left. That last bit was the reference angle because it's formed with the nearest x-axis. We're going to triangle it out. The short leg would be 1. The hypotenuse is twice the short leg, and the long leg is the short leg times √3. Both of these pieces are negative because you're running left and you're falling. Now, by the way, mentioning ASTC, I'm finding tangent. It's supposed to be positive, and it is because tangent is opposite over adjacent, so -√3 over -1. That just gives me a -√3. Last one I'm going to do is 14, which is the cosecant. Remember, that's Santa's favorite ratio. Ho, ho, ho. Cosecant of 315 degrees. She is a positive angle. She will rotate counterclockwise. She'll rotate 180, 270, 45 degrees of positive rotation left. And the 45, 45, 90 pattern that most kids memorize is 1, 1, √2. This one is negative because it is falling. If you think about ASTC, cosecant is going to be negative in this quadrant. And she is because she's hypotenuse over opposite. By the way, the reference angle is 45 degrees. So √2 over -1, which is -√2. Easy peasy lemon squeezy. I don't have too much left to do here. I'll leave that one blank. Let's see, use the given point on the terminal side of an angle theta in a standard position to evaluate the given trig functions of theta. I expect to see drawings. All right, so let's look at 17. We're tasked with finding cosecant and cotangent. So first off, we just have to plot the point. To get to this point, you go right and down. You go right 5 and you go down. Let's triangle that point out. You put theta in the origin there. You went right 5 and you fell a root of 11. The oldest theorem we have gives you the hypotenuse. We're going to do 5 squared plus a -root. 11 squared is c squared. That's going to give me 25 plus 11 because if you square a radical, you get the number. Sorry, if you square a square root, you get the number inside. That'll give me 36 is c squared, so c is 6. Hypotenuses are always positive whether you want them to be or not. Next up, we're tasked with finding the cosecant of theta. Cosecant is Santa's favorite ratio, hypotenuse over opposite. That's 6 over -√11. We clean it up by multiplying the top and bottom by √11. We get 6 √11 over 11, and she is negative because we had a negative over a positive. We're also tasked with finding the cotangent ratio. The cotangent one is the excited one. It says AO. So it's adjacent over opposite. 5 over -√11, multiply top and bottom by √11, and we get 5 roots of 11 over 11. Don't forget the negative symbol. Easy peasy lemon squeezy. All right, what do we got next? We got 18. 18 ought to be an easy one. So should 16, because those are special patterns in math. Let's see, we have to go back 3 and rise 4. So that put me about right here. I went back 3, and then I went up 4. That, boys and girls, is what you call a 3, 4, 5 right triangle. Now, if you have never heard of that, I don't know how you got credit last year for geometry. It's a 3, 4, 5 special right triangle. Remember, we always put theta in the origin, and then we're just going to hit it with our ratios here. The cosecant of theta, that again, that's Santa Claus's favorite ratio, hypotenuse over opposite, 5 over 4. And we have the secant. Secant's the funny guy. Hypotenuse over adjacent, -5 over 3. And that is it. That's all your homework that I care to do today. Maybe you can figure out the rest of it. I don't know. We'll find out.